So in this lesson, we're going to be talking about systems of equations, and we're going to learn two different methods. One's called the substitution method, and one's called the elimination method, or sometimes it's called the linear combinations method. And depending on what I see in the equations will depend on which method I choose, me personally. And both are fine. You can use either method, but generally, depending on what you see, will help you do it faster. So, systems of equations basically is talking about more than one equation where you are looking for the intersection. For us, most of the time that means that we're going to be involving x and y. You'll find out in the next lesson, the one that you're going to watch on video on Monday, that there is one that actually has three. It's a three-dimensional set of equations, but that doesn't really matter. When you use matrices, there's a very fast way to solve that. It's just talking about the intersection of three different equations in three-dimensional space, which is kind of cool. So let's talk about the first example. And we're just going to do a ton of examples here. So the first example, you'll notice how the y is all by itself. Whenever you see one y, positive one y, all by itself, you want to use the method called substitution. And what that means is this. Let's say, for example, I have a $10 bill and I want to buy something, but I don't have change to buy something cheap, and neither does the cashier. So I turn to Fiore and I go, Fiore, do you have change for a 10? She's like, yeah, I have a 5 and 5 $1 bills. So she hands me the 5 and the 5 ones, and I give her my $10 bill. Why? Because those two things are exactly the same amount of money, just in different looking fashion. That's called substitution. I substituted my $10 for a $5 bill and 5 ones. And so in equations, it works the same way. And what I notice is in the first equation, I see this y here, and I see the y there. And that means in the second equation, wherever I see that y, I can replace it with the stuff that comes after the equal sign. So what I'm going to do is I'm going to write down the second equation, negative 10x minus, is that a 5?
Yeah.
5 times parentheses something equals negative 30. And in that something is whatever I saw up above that the y was equal to, which is 15 plus 8x. Now that stuff that I saw there, that I'm substituting, is the same thing as a y. So that's why I'm putting it in for the green stuff. And what you'll notice in this new equation is there's only one letter, one variable. So now I can solve for that one letter. So I do that now by rearranging stuff. So I have that negative 10x, and I have negative 5 times 15, which is negative 75. I have that negative 5 times 8x, which is minus 40x, and it's all equal to the negative 30 on the other side. I see that on the left-hand side I have two x things. You guys see that? Negative 10x, negative 40x. I put those two things together, negative 10x and negative 40x, and when I combine those like terms, I get negative 50x. And then I still have the minus 75, and it's all equal to the minus 30. So now I have x things on the left side, but I have numbers on both sides. I don't want that. So I move the 75 to the right-hand side by adding 75 to both sides. If I add 75 to both sides, the 75 on the left-hand side, which was negative, now disappears, because negative 75 plus 75 is 0. And then on the right-hand side, I get 75 plus 30, negative 30, which gives me a total of 45. Let me pause there. So now in order to find out my x, I'm going to divide both sides by negative 50.
Yep.
So if I divide both sides by negative 50, I get that my x value is equal to that 45 divided by that negative 50, or in other words, negative 0.9. That's my x value. So you found x, but you don't have y. The way you find the y value is you take that negative 0.9 and you shove it back in to the very first equation that I used as a substitution equation, wherever you saw the x, and then you find the answer. So what I'm telling you is, when you look at that, what you see is that your y value is going to be equal to 15 plus 8 times that negative 0.9. So y comes out to be whatever that is when you multiply that all out and add. So in this case, my y value is 7.8. What does this mean? This means that when you look at these two things, what you're seeing is that these two lines that we started out with are crossing at negative 0.9, 7.8. That's what it's saying. So I have two lines, and that's where they cross. So now in this second example that we see, we notice that the x is all by itself. So as I look at that x being all by itself, I'm going to take all the x stuff that I see there and substitute it into the first equation. So whichever equation has the variable alone and positive, with a 1 in front of it, like in this case the x, the stuff on the other side you shove in for that letter. So the top equation now becomes 10y minus 2 times whatever I'm going to shove in there, and that's going to equal 6. What am I shoving in? 4 minus 2y. So I take that 4 minus 2y and I shove it in there. That's what I substituted in. The yellow highlight. Notice how this pink equation and purple now only has one letter. So I only have to work with one thing. So when I simplify that, I get 10y minus 2 times 4, which is 8, and then minus 2 times minus 2y, which is positive 4y, and on the other side I still have my 6. I now see there are two y things on the left side of the equation, so I take the 10y and the 4y together. That makes a total of 14y. And I still have that minus 8, and it's still equal to 6. How would I get rid of that minus 8? Add 8, very good. Add 8 to both sides. So if I add, the reason I'm adding 8 is on the left side, the 8 goes away then. And then when I add 8 to the right side, I get 14y equals 14. What does that mean my y is equal to? 1. So now I write down that my y is equal to 1. And I have that solution. But I'm not done yet, because I need to figure out what the x is. So now I take this y equals 1 value, and I shove that back into my equation over here for the y. When I do that, I get that my x value is going to be equal to 4 minus 2 times that y value that was a 1. So x equals 4 minus 2 times 1, which means my x is 2. And this is talking about, I know that the place where they cross is 2 comma 1. That's the ordered pair where they cross. In the rest of these equations, I'm going to show you a different method. So the first two were the substitution method. The rest of these are called the elimination method. The elimination method is just what it sounds like. We're going to try to eliminate one of the variables. Doesn't matter which one, we pick one. Now when you're doing this, which is also called linear combinations, what you want to do is you want to make either the x's or the y's turn into the same number, but have one be positive and one be negative. That's the goal. Because if you could do that, you can eliminate one of the variables. So we learned earlier that in math, if you're solving an equation, you can do the same thing to both sides of the equation. Like for example, what we've been doing is like when we want to get rid of the negative 8, we added 8 to both sides. We're going to do the same kind of thing in the beginning, but we're going to multiply first. So as I look at number 2, I notice that number 3, I notice that the y's, as I look at them, are negative 2y and positive 2y. Wow, they're already the same and they're opposite. So right away, what I can do is I can look at those and go, hey, let's add those two equations together. When I add them together, 3x plus 4x, that's 7x. Negative 2y and positive 2y are 0 y's there, so I don't have to write anything down. And 17 plus 4 is 21. If I now divide both sides by 7, excuse me, I was looking ahead to the answer. If I divide both sides by 7, I find out that my x is going to be 3. So already, I found my x value. At this point, you can choose any equation in the system and plug that number back in. Doesn't matter. So I try to avoid negatives when I can. Doesn't really matter. You can use either one. But I'm going to choose the second equation. It won't matter which one you choose. Pick either one. What I do now is I take that number 3 and I shove it in for the x in the second equation. Or in other words, I know that 4 times 3, which was the x value, plus 2y equals 4. So the 3 was the x, I put it in for the x, and now I'm going to solve this. And look, I only have one variable left. So 4 times 3 is 12, plus 2y equals 4. Darn it, the y thing is not alone. I have to get rid of the 12, so I subtract 12 from both sides. If I subtract 12 from both sides, I will end up with a 2y equals negative 8. Because 12 minus 12 is 0, and 4 minus 12 is negative 8. What should I do now? Divide by 2. Thank you, Nick. Divide by 2. If I divide by 2, my y value is negative 4. So now I know that my x was 3 and my y was negative 4. Again, if you're writing this as ordered pairs, it's not necessary, but if you did, you would see that you have your ordered pair 3, negative 4, and that's where these two lines are crossing. In number 4, you will notice that in both equations, we have 2x. You guys see that? But they're both positive. So if I were to add them up, I'd get 4x. That's no good. I want them to be opposite signs. So what I'm going to do in the first equation is I'm going to multiply everything by negative 1 on both sides of the equation. Because remember, we can add to both sides of the equation, multiply both sides of the equation, subtract, divide, as long as we do it to both sides. So I'm going to take that first equation, and I'm going to multiply both sides by negative 1. If I multiply both sides by negative 1, I see that I get negative 2x first. Negative 1 times negative 3y is positive 3y. And negative 1 times, what is that number? Times negative 5 is positive 5. And now what I do is I look at, I don't look at the first equation anymore because I changed it. I look at what I changed it into. So now I'm looking at this equation and this equation, highlighted in green. And just like I did in number 3, I add those two equations